Lesson 89, diagonals, interior angles, and exterior angles. So a diagonal, by definition, is a line segment connecting two vertices and passes through the polygon. So we are going to draw a hexagon. And if you label it A, B, C, D, E, F. So AF is a segment that connects two vertices, but it does not pass through the polygon. So AF is not considered a diagonal. But AE would be a diagonal, AD and AC would be a diagonal. So AE, AD, and AC. So this has 4 triangles. If you notice, there are 4 triangles that are formed if you draw just the diagonals coming from one vertex. So it has 4 triangles. So if you want to find out how many triangles it has, you take the number of sides of the polygon, subtract 2, and that will give you the number of triangles that are formed when you divide it up, just using one vertex. So in this case, we had 6 minus 2, and we had 4 triangles in this example. So if every triangle has angles that add up to how many degrees? Do you remember? 180 degrees. So if you did 180 degrees times the number of triangles, that's going to give you the total of all of the interior angles of this particular polygon. So if we did 180 times 4, it would give us how many, all the interior angles, the sum of the interior angles. So we'll put, this is going to equal the sum of the interior angles. So remember, to find the number of triangles, you take 2 less than the number of sides. So here is another figure. We're going to draw an octagon. We'll call it GHIJKLMN. Each of these angles, angle G, angle H, angle I, those are all considered interior angles. So interior angles. Some examples, we'll have angle NGH. So if you start at N, G is the vertex, end at H. That's an interior angle. Angle GHI, etc. So you could list all of them all the way around. If you want to find the angle measure of each interior angle, we can do that if the polygon is regular. So regular just means all the side lengths are the same. That means all the interior angles will be the same. So in a regular polygon, the sum, if you take the sum of the interior angles, which is, we told how to find it up here, 180 times the number of triangles, divide by the number of angles. In a regular polygon, the number of angles is the same as the number of sides. That's going to equal the measure of each angle. In your book, if we look at example 2, you will see an example of finding the measure of each angle. So, example 2, they had a regular hexagon inscribed in a circle. Hopefully you guys remember inscribing hexagons in a circle with a compass. To find the measure, you take the sum of the interior angles. So we do 6 minus 2, which is 4, times 180, and you get 720. So the sum of the interior angles will be 720, and then they divide by the number of angles, which there was 6. So if you did 720 divided by 6, the measure of each angle would be 120 degrees, which they show that in example 2. So we're not going to write the example down because you can just look at example 2. So I'm going to write right off to the side here, just write C example 2. That way we don't have to write down that example. If we have a, oh, there's another one, example 3. They had a 4-sided polygon. It's not regular, it's not a square, but you can find the sum of the measures of the interior angles by just doing 180 times 2, which is 360, because it would divide it into 2 triangles. Okay, then we have what's called exterior angles. Those are all the angles that are outside the figure. So exterior angles, let's see, I would like to draw a hexagon. I'm going to draw it over here. And I'm going to draw the exterior angles so you can see what they look like. It's kind of like if you extend one of the sides out. This measure right here is an exterior angle. So if you extend out this side, that's an exterior. These ones are all the exterior angles. Imagine if this were a pathway that you were walking, okay? And you started here, and you walked and turned, walked, okay? How many degrees do you think you would walk if you went all the way around the pathway? How many do you think? All the way around. How many degrees do you think? What do you think?
360.
360 degrees. So the exterior angles of a polygon always add to 360 degrees. So if you had a regular polygon, actually, any polygon, they're going to add to 360. But for a regular one, you could figure out how many degrees each turn is. So exterior angles always add to 360 degrees. So in a regular hexagon, if we did 360 divided by 6, each exterior angle would be equal to 60 degrees. So each of these would be 60 degrees. Now if you notice, this one's exterior, the one right next to it is interior. Every exterior angle and interior angle that are next to each other are supplementary. That just means they add to 180. So if you know an exterior angle, you can just subtract from 180 and get the interior angle. So the measure of each pair of exterior and interior angles are supplementary. Actually, we wouldn't have to put measure. We would just write each pair of exterior and interior angles. So just scratch out the measure of. We actually don't need that sentence. Okay, that's it. That's the end of the lesson. Stop there.